This week, we're stepping into another crucial aspect of Python, the built-in data structures. Python provides developers with an array of data structures to manage and manipulate information effectively. We'll be focusing on lists, tuples, dictionaries, and sets, all while uncovering their unique characteristics and use cases. So if you're ready to elevate your Python programming to the next level, let's dive in for today's episode. Welcome to PyPod Chronicles, a series that brings our tech blog to life in a whole new way. Covering an array of topics surrounding Python and tech, from programming tips, best practices, and so much more. Let's get immersed in Python with the Nerd Nook on the go. Welcome back, guys, to another episode of PyPod Chronicles. If you're new here, I'm Josh, your host. And if you're coming over from my blog over there, you probably know me as Rusty Raccoon, or from the channel, Code with Josh. I'm stoked to have you guys here. Here I am in episode 22, and this one is all about the next step of mastering Python. But it's the ultimate guide to mastering the built-in data structures of Python. And before I dive into today's episode, guys, if you're new here, spread the love and subscribe. I've made you guys a free Python guide that I'm giving out to you. All you gotta do is head down to the link in the description, head over there and pick up your free copy that you can use to start your Python journey. Let's start off with your go-to sequence container. Josh, what do you mean by that? Well, I want to kick things off with lists. And they're perhaps the most versatile and commonly used data structure in Python. They allow you to store a collection of items in a specific order. And the items can be of any type of data, so integers, floats, strings, other lists, you name it. Every item in a list is actually now called an element. And all we need to do to create a list is simply enclose the items within square brackets, the elements, or you can use the Python list function, the list constructor function. So for example, I could make a list of fruits. Fruits equals square brackets, and inside there I could put 3 strings, apple, banana, and orange. Right? I just made a list. Now, what are some characteristics of lists? Well, lists are mutable, and this means you can modify their contents after you create the initial list. You can also index or get a specific element from a list by using its position within the list. Another cool thing with lists is they provide various methods. These are functions that we can use while working with this data structure, like append, insert, remove, you name it, there's a bunch of other ones too. If we wanted to list the index, the word index literally means position of something. So what is the position of an element in a list? What is the index of an element in a list? It's the same meaning. Python uses a zero-based index, as do most programming languages, where the first element is at index position 0. To get the index of an element, all you gotta do is take the name of your list, followed by square brackets. Inside the square brackets, you're gonna put an integer. This integer represents the index. So in my previous example, if I had a list of fruits, apples, oranges, bananas, I could index apple by saying fruits 0. The value of that will be apple. If we want to add items to an existing list, well, I can use the append method. In English, append literally just means add. So I can take my list, fruits, append. Inside append, I could put what I want to add to my list, like grape. Grape would go to my list. Or if I want to add multiple numbers to a list, I could use the extend method. Extend could take another list, and this would be added on to my current list. And then the opposite of append, well, is remove. If you want to remove an item, you can just use the remove method and put the item you want to remove from your list. This makes lists incredibly powerful. Now, some practical use cases, well, I could store collections of data for processing. Maybe I could manage records in a database. Or I could store coordinates for graphical applications. You name it. Lists are a cornerstone of Python programming, and they offer flexibility, versatility, and dynamic data management. You now learn the first data structure. Let's talk about immutable and unchanging, the sister of a list. In Python, a tuple is an ordered collection of elements enclosed with parentheses. Tuples are very similar to lists, but they come with one crucial difference. Once created, lists are immutable, meaning you cannot alter the contents of a tuple. The methods we learn while working with a list, append, remove, we cannot use those with a tuple. Creating a tuple, though, is super straightforward. It's just like a variable equals parentheses. Inside the parentheses, you would put elements, just like a list. So the only difference in the setup is a tuple uses parentheses, and a list uses square brackets. Tuples are immutable, so you cannot change their data. It is fixed. Just like a list, you can index the position of an element, right? So think of like coordinates. If you change the coordinate, it's going to be a whole new position on the map. So that would be perfect for a tuple. Some use cases of this, well, I just said coordinates. You could have RGB color values, right? Maybe you're returning multiple values from a function, so you could store those in a tuple and then use those on the outside. Tuples play a pivotal role in Python programming because they offer immutability and data integrity. All right, the first two are down. Now moving on to dictionaries, mapping keys to values. Dictionaries in Python are powerful data structures used to store data as key value pairs. Unlike sequences, so lists and tuples, which are indexed by a range of numbers, dictionaries are actually indexed by keys. And this key value mapping allows for efficient data retrieval. And it's literally like a dictionary, because if you open a real dictionary, there's a word that has a definition. Well, a Python dictionary is pretty much the same thing. Creating a dictionary involves pairing keys with their corresponding values, all while using colons and enclosing these with curly braces. If you remember anything, remember this quote, or my saying here that I tell my students. Dictionary, key, value. Dictionary key unlocks a value. The key can only be an immutable type of data, while the value can be any type of data. To create a dictionary, just use the curly braces. For example, if I had contact information, I could have a dictionary called contact equals curly braces. Inside there, I have three key pairs. I have name, that's the key, and the value of name would be subscribe. I have a key called email, and the value of email could be an email address, right? And the final one could be something else. Some characteristics of dictionaries are they offer fast access and retrieval based on keys. The keys are unique and immutable, while the values can be any type of data and the values are mutable. You can modify, add, or remove key value pairs super easily. If you want to access a value, remember, dictionary key unlocks a value. So you just have to give the dictionary with a key, and that's going to return you a value. Pretty cool. Some use cases for these, well, there's a lot. You could store configuration settings for your applications. You can manage data in real-world entities like users, products, or locations. Maybe you want to represent JSON-like data structures. Well, that's what we use a dictionary for. This brings us to our final one. So I've touched on lists and tuples, and those two are quite similar. I now introduce dictionaries, which are my favorite, and they have key value pairs. Now the final one is a set, and a set is unordered, unique elements. Sets in Python are collections of unique elements. Unlike lists and tuples, sets do not allow duplicate values, making them an excellent choice when you need to ensure distinctiveness. Sets also enable efficient set operations like union, intersection, and difference. Anytime you do not want a duplicate value, sets may be a great choice for you. And sets, are kind of just like a list or kind of just like a tuple. But the main difference is you cannot have duplicate values in them. Create a set, though, it's like a dictionary. We use curly braces, but this time we just give single elements like a list or a tuple. The characteristics of sets, they automatically eliminate any duplicate values. I can perform unique sets of operations like union, intersection. I want to talk about those here shortly. In order to add elements to a set, you can use the add method. Add works just like a pen. And then you could also use the remove method that comes with list, or you can use the discard method. Both of these work pretty much the same. But the unique ones, for example, the intersection method. I can only use intersection with sets, and this computes the intersection of two or more sets, and it returns a new set containing only the elements that are common to all the sets involved. That's really cool. Or maybe we want to merge two sets together and create a new set. For this, I could use union. Union combines two sets and creates a new one. And the last one would be difference. And difference is like the opposite of intersection. Difference is going to create a set based on the difference or the different elements between the sets involved. Practical use cases, well, I can think of a few here. Determining common elements between different sets. Maybe I could verify data uniqueness in our applications, or I could try counting distinct items in a large data set. When it comes to data, I'm going to be coming out with episodes on that shortly. Some key differences: lists and tuples. Lists are mutable, allowing for changes, whereas tuples are immutable, ensuring the data integrity. Lists are suitable for dynamic collections of data, while tuples are great for fixed data like coordinates and configuration. The other two, dictionaries and sets, while dictionaries focus on key value mapping and pairs, they're great for situations where you need to associate data with unique identifiers, or like keys per se. And sets, on the other hand, they emphasize distinct values, so they're pretty good for removing duplicates from a list. To wrap up the episode today, right? This is the next step to master the fundamentals of Python. You're embarking on this incredible journey to understand not only Python, but the built-in data structures it comes with. Today, in our episode, we talked about our 4 data structures: lists, tuples, dictionaries, and sets. As a mini project, I want you guys to try to create yourself a mini database for storing users. Every user can have multiple characteristics like a name, age, hobbies. It's up to you. And find a way to add new users, search for users, and anything else you want to do with that database. Hint, hint, use a dictionary for the main database. Alright guys, that wraps up to today's episode. Remember, if you're new here, subscribe. Help us grow as a community. And I have a free handcrafted Python guide for you. It's the first link down in the description. Head on down there and grab yourself a copy that you can use through your programming journey. Head over to YouTube and check out my channel, Code with Josh, as I have interactive tutorials with material I've made for you to help you learn these fundamentals of Python. Well, I had a blast. Until our next episode, I will see you then. Thanks for tuning in for another episode of PyPod Chronicles.